Hello everyone, welcome back to my channel. So in this video we will see about differential manometers. Do watch my earlier video where I have discussed about simple manometers and the types of the simple manometers. So coming to differential manometers, so differential manometers are those devices which are used for calculating the pressure of a fluid at a point, but here uh, the fluid column is not open to the atmosphere like in case of a simple manometer. If you remember, when I've told the definition of manometer, I told that it is the device which is used for calculating the fluid pressure at a point by balancing the fluid column by the same or another column of fluid. So if you are balancing one column of fluid by another column of fluid, you call it as a differential manometer. And hence in differential manometer, we will not calculate the pressure directly. Instead we will calculate the difference of pressure between the 2 points, because there are two columns now. Okay, so basically a differential manometer consists of a U-tube manometer, which generally consists of a heavy liquid, which means which is heavier than the liquids which is in the two columns, and this is connected to the differential manometer. And mostly observed two types of differential manometers are U-tube differential manometer and inverted U-tube differential manometer. And now in this video we will see about them. Coming to the first one, it is a U-tube differential manometer. So you can see here we have two pressure points A and B, and we can see the U-tube which is fitted to the points A and B to calculate the pressure at points A and B. And you can see the shaded area which says that it is containing a heavy liquid than the other liquids, like in the column A and B. Sometimes same fluid can be at A and B, and sometimes different fluid can be at A and B. And in this U-tube differential manometer, we will solve for two cases. One is when the two pipes, that is pipe A and pipe B, are at different levels, and when pipe A and B are at the same levels. So in this case, let's see when they are at the different levels. So you can see here we have 2 points A and B connected, which are at different levels. They are also having liquids of different specific gravity. So liquid in A is different, liquid in B is different, and both of them are connected to the U-tube manometer. Okay, and the difference of heavy liquid in the U-tube manometer is H. And as I've already told, let the pressures at A and B are PA and PB. So if you see here, H, as I've already told, H is the difference of heavier liquid. In this case, let's say it's mercury, so H is the difference of mercury level in the U-tube. And if you see about Y, so Y is the distance from the center of B to the level of mercury in the right limb or the right column. And if you see X, it is the distance from the center of point A to the uh, uh, column of mercury or the height of mercury in the right limb. Okay, and rho 1 is the density of liquid in A, and rho 2 is the density of liquid in B. And let's say rho G is the density of this heavy liquid, and we are taking XX as datum. So the procedure of solving for pressures is same. We write the pressure on the left side, we write the pressure on the right side with reference to datum, we equate both. So similarly, if you see on the left hand side, the pressure on the left hand side, there is point A, hence the pressure at A will be counted, so PA plus, because of this liquid rho 1, there will be pressure created. So rho 1 will be equal to, to say pressure because of this liquid will be equal to, formula is rho GH. So it should be rho 1 G into height. Height is X plus H. Okay. So PA plus rho 1 G into H plus X, because from here to here it is X, but we are doing with reference to datum. So with reference to datum, from here to here the height is H. So it is rho 1 G into H plus X. And if you see the pressure in the right limb, so because of at point B there will be pressure B, so it's PB plus, because of this liquid it's rho 2 GY, and because of this H it is rho G GH. So finally the pressure in the right limb is PB plus rho 2 GY plus rho G GH. And once you equate both the pressures and solve, you will get the value of PA minus PB as H into G into rho G minus rho 1 plus rho 2 GY minus rho 1 GX. Okay. And let's say if the points A and B are at the same level. So once they are at the same level, you will not have a question of X and Y as in the earlier case. Okay. We have only X here. Okay. Yeah, so when the 2 points A and B are at the same level, so as I've told, we don't have pi, so directly we will write pressure in the left column, pressure in the right column, and equate both. So the things are the same with the earlier case. So if you see what is pressure on the left hand side, the pressure on the left hand side will be the pressure due to A, that is PA, plus because of this liquid. And also let's say that since they are at the same level, let's say that the liquids are also same. So what will happen? So it will be Pa plus rho 1 G x plus H, because from here till here the distance is x plus H. So it's Pa plus rho 1 G into H plus X or X plus H. If you see on the right hand side, it will be the pressure at B, that is Pb plus, as I've told, two liquids are same, so this liquid also will have the density of rho 1. So it is Pb plus rho 1 Gx and rho G Gh. Okay. And therefore you equate both the pressures and calculate Pa minus Pb. You will end up with G into H of rho G minus rho 1. And moving to the next type in differential manometer, which is the inverted U-tube. So now the U-tube is completely inverted, and here you can see, now one has to remember that in the earlier cases whatever we have seen, the U-tube manometers or the differential manometers or the simple manometers, they were normal. So we took a liquid which is heavier than the liquid which is flowing in the pipe A and B. But now since the manometer is inverted, we will take a liquid in the U-tube whose specific gravity is lighter than the specific gravity of this and this liquids. Okay, that is the difference, we have to note it because it's inverted. So I will have a density of fluid, I will have a fluid whose density in the U-tube is less than the densities at A and at B. Okay, so now the datum will be shifted upwards. And yeah, as I've already told, so U-tube will contain a lighter liquid and its two ends of the U-tube are connected to the 2 points A and B. So we generally calculate difference of pressure, and the figure shows the inverted U-tube differential manometer. Let the pressure at A is more than B so that I can calculate Pa minus Bb. So let's see what is H1, height of the liquid in the left limb above XX. So below XX. So XX is here, and from the center of A till XX in the left limb it is H1. What is H2? Height of liquid in right limb. So if you see here, from the center of pipe B to the mercury level below XX, the height is H2, and H is the difference of the mercury level. Okay, sorry, I should not say mercury now, difference of a lighter liquid. Now let's say rho 1 is the density of liquid at A, whose specific gravity is S1. So we will get rho 1 is equal to S1 into 1000, and let's say there is another liquid of specific gravity S2 in B, so rho 2 will be S2 into 1000. Okay, and yeah, Pa is the pressure at N, Pb is the pressure at B. So if you take XX as the datum, what is the left pressure in the left column? So remember another difference, people, between the other manometers and inverted manometer. First difference is what? In the U-tube the liquid is lighter than these two liquids at A and B. Second difference is that till now we were writing like Pa plus rho into something something like that, because we were moving from down to up, but now here the datum is at up and we're coming down, so here we will write minus. Okay, so pressure in the left side will be equal to Pa minus rho 1 Gh1. So because its pressure at A is Pa, pressure at A is Pa, and datum is upward, so it is minus rho 1 Gh1. Okay, what will be the pressure in the right column? It will be Pb minus rho 2 Gh2 minus rho SGH. Rho S is specific gravity of, density of the lighter liquid. Okay, we generally say rho G for heavy liquid, no? So rho S for lighter liquid. So now equate both the pressures, you end up as Pa minus Pbs rho 1 Gh1 minus rho 2 Gh2 minus rho S Gh. So this is how we solve inverted U-tube differential manometer. So I hope you understood the concept of manometers. Thanks for watching.